Assalamu alaikum. Hello viewers. Today I am going to discuss with you some problems from functions, and also I will show you the definition of functions and some formulas. First of all, we have to know why do we study functions. Many situations in a real world that can be modeled as functions. Some examples are temperature of a hot drink as it cools over time, the depth of water in a conical container as it is filled from a tap, the number of bacteria present after the start of an experiment. Modeling these situations using appropriate functions enables us to make predictions about real life situations, such as how long will it take for the number of bacteria to exceed 5 billion. Definition of a function, mathematical definition. Uh, Function is a relation that uniquely associates members of one set with members of another set. An alternative name for a function is a mapping. A function can be either a one-one function or a many-one function, but remember it can't be one many relation. Okay. Function is a kind of a relation. We can also say that where we get a output from input. uh, uh, it can, if it is a relation between two sets, then it can be one relation, many one relation, but can be one to many relation. Okay, so now we see some examples here. This is a function x from x map to x plus 2 where x belongs to R is an example of a one function. So here we get one output for each input value. If we put the value of x, we get for each value of x we get one value of y. Okay, we can write this function if such that x map to x plus 2 where x belongs to R, or f of x is equal to x plus 2 where x belongs to R. The function x map to x square where x belongs to R is a many one function. Okay, uh, so many one function has one output value for each input value, but each output value can have more than one input value. Okay, we can write this function as f such that x map to x square for x belongs to R, or f of x is equal to x square for x belongs to R. So f such that x map to x square is read as the function f is such that x is mapped to x square, or f maps x to x square. Okay, so this is also a function, but if we put a value of x, we get 1. If we for each output value can have more than one input value, I mean many like if we put the value of x minus 2, okay, then the value of y will be 4. Okay, and also if we put the value of x is 2, then we get the value of y is 4. So for each output value can have more than one input value. This is what they try to say. Okay, now uh, if we consider this graph, which is y square equal to x, we can see that the input value shows has two output values. Okay, this means that this relation is not a function. Suppose if we take the value of x is 4, then y will be plus minus 2. So this can't be a function, because the input value shown has two output values. One input value we get two output values. So it becomes a one many relation, which is not possible in function. Okay, in the definition of function we see that it is a relation that uniquely associates members of one set with the members of another set. Okay, so set of input values for a function is called domain of the function. Set of output values for a function is called the range of the function. Okay, or also called codomain of the function. Now problem 1. Viewers, see the problem 1. Here we are given the function f map to x square minus 4x plus k is defined for the domain x greater than or equal to p, where k and p are constants. We have to express f of x in the form x plus a whole square plus b plus k, where a and b are constants. We have to state the range of f in terms of k. We have to state the smallest value of p for which f is 1 1. For the value of p found in part 3, find an expression for f inverse x and state the domain of f inverse, giving your answer in terms of k. Here f of x is equal to x square minus 4x plus k. Then f of x is equal to x minus 2 whole square minus 2 whole square plus k. That f of x is equal to x minus 2 whole square minus 4 plus k. We transform it to this x square minus 4x plus k to this equation. Both are same, but we just transform. Here we bring x minus 2 in the place of x, and now the graph of fx is which is f of x is equal to x minus 2 whole square minus 4 plus k, is a u-shaped parabola. It has a vertex or minimum point at 2k minus 4, and the minimum value of fx is k minus 4 when x is equal to 2. The range of fx is f of x greater than or equal to k minus 4. Okay, now for a 1 1 function, x always will be greater than or equal to 2. Okay, f of x is equal to x square minus 4x plus k. Here we are going to find the f of f inverse x in the number in part 3. We have to state the smallest value of p for which f is 1 1. That's why we write that for a 1 1 function x will be greater than or equal to 2. Now f of x is equal to x square minus 4x plus k. If we let y equal to fx, then y is equal to x minus 2 whole square plus k minus 4, and we bring x minus 2 whole square this part to the left hand side, then we get the value of x is y plus 4 minus k. Here we take only the positive value because the domain of the inverse will be x greater than or equal to k minus 4. That's why we have to take the positive value only. Now x we can write in the place of x is f inverse y, which is 2 plus y, 2 plus root over y plus 4 minus k. So f inverse x is 2 plus root over x plus 4 minus k. The inverse function exists because it is a 1 1 function for x greater than or equal to 2. The domain of f inverse x is the same as the range of fx, so the domain of f inverse x is x greater than or equal to k minus 4. Okay, now problem 2. Here we have been asked to express this x minus x square plus 6x minus 5 in the form a times x plus b whole square plus c, where a, b, c are constants. Then the function f such that x map to a minus x square plus 6x minus 5 is defined for x greater than or equal to m, where m is a constant, and we have to state the range of f. Then we have to state the smallest possible value of m for which f is 1 1. Then in part 4, for the case of m, if m is equal to 5, then find the expression for the f inverse x and state the domain of f inverse. Here we transform this minus x square plus 6x minus 5 to minus bracket x square minus 6x plus 5. We can write this in this form x minus 3 whole square minus 3 square, so it becomes minus x minus 3 whole square plus 4. So graph of f such that x maps to minus x square plus 6x minus 5, or f such that x map to minus x minus 3 whole square plus 4 is an this shaped reverse V or U shaped parabola. This the vertex maximum point is 3 4. Okay. However, for 1 1 function x greater than or equal to 3, smallest possible value for m is 3. Okay. Now part 2, range of f of x is f of x less than or equal to 4, because if we see the in the part of fx, we will explain it from the f inverse. Okay. Now here if we take y is equal to minus x plus 3 whole square plus 4, we can bring the x, this part to the left hand side, then we get the value of x is 3 plus root over 4 minus y. So x equal to f inverse y, it will be is equal to 3 plus root over 4 minus y. We can write this f inverse x is equal to 3 plus root over 4 minus x. Here if we see the f inverse part, this part becomes greater than or equal to 0, so 4 will be greater than or equal to y. So then as m is equal to 5, then x greater than or equal to 5, so then the inverse function exists because it is a 1 1 function for x greater than or equal to 3. The range of fx is f of x less than or equal to 0 when x greater than or equal to 5. So the domain of f inverse x is x less than or equal to 0 when m is equal to 5. Okay. Now we are given two functions f and g here are defined for x belongs to R by f map to f such that x map to 2x plus 1, g such that x map to x square minus 2. First part, find and simplify the expression for f gx and g fx. Then find the value of a for which f g a then g and is equal to g f a. Find the value of b where b not equal to a for which g of b is equal to b. Find and simplify an expression for f inverse gx. The function h is defined by h such that x map to x square minus 2 for x less than or equal to 0, and also find an expression for h inverse x. Here f of gx is equal to, we can write f of x square minus 2, so this becomes 2 times x square minus 2 plus 1, so it will be 2x square minus 4 plus 1, so it becomes 2x minus 3. So g of f of x, it becomes a g of 2x plus 1, so it becomes 2x plus 1 whole square minus 2, so it becomes 4x square plus 4x minus 1. Okay. Now in second part, we are given that f of g of a is equal to g of f of a. We have to find the value of a. Then from f of g of a we get since f of g of x is equal to 2x square minus 3, so then if we put the value of x is a, then it becomes 2a square minus 3, and this part becomes 4a square plus 4a minus 1. So if we bring the right hand side to the left hand side, then we get the value of a is minus 1. Similarly, if g of b is equal to b, then g of b becomes b square minus 2, so this becomes b square minus b minus 2 is equal to 0. The value of b will be 2 and 2 or minus 1, but b not equal to a, so b is equal to 2. In part 4, first we have to find the value of f inverse x, where let f y equal to fx, so then y is equal to 2x plus 1, the value of x will be y minus 1 by 2, so f inverse y is equal to y minus 1 by 2, f inverse x equal to x minus 1 by 2. That means f inverse gx is equal to f inverse x square minus 2, that will be 1 out of 2 times x square minus 2 minus 1, 1 up to 2 times x square minus 3. Here if we define x h such that x map to x square minus 2 for x less than or equal to 0, we let y equal to x square minus 2, x square becomes y plus 2, x equal to plus minus root over y plus 2, the x will be h inverse y, that means h inverse x equal to minus root over x plus 2. So this is h inverse x. Here we take the negative value because domain of hx is x less than 0. That's why we take only negative value here. So that's all I try to discuss with you from the topic function. I hope this will help you to understand the topic more easy, and please subscribe my YouTube channel, and you can let me know in which topic you find it difficult most, then I will try to make that easy for you, and hope you all the best. Assalamu alaikum.